Hello. Today we will be discussing an AI safety article published last week. It's called Self-exfiltration is a Key Dangerous Capability. It was written by Jan Leike. He's an ML researcher, machine learning, AI safety researcher. He's co-leading the super alignment team at OpenAI, and this was a post written just a few days ago. It's definitely a development this year where I'm feeling like AI safety is becoming more important. It's paramount. I'd say even bigger than the topic of AGI or artificial superintelligence itself. It seems like AI safety is the topical thing that we should all be thinking more about. And so I thought it'd be fun on the channel to summarize this article, discuss it, maybe help educate. I got to give you a disclaimer. I'm not an AI researcher. I'm definitely not an AI safety researcher. But these ideas, I think, are very important. And so I'm going to try my best here. And of course, I encourage everybody in the comments, if there's something I get wrong, if there's anything you have to add to this discussion, please put in the comments below so that everyone can learn and benefit. All right, let's jump in. So this is what the article looks like. It's on Substack. The link is at the bottom, and of course, the link to these slides are going to be available in the YouTube description below. This is basically what the article looks like. In today's video, I'm just going to basically summarize the article, pick out some key highlights, and then later, share some open-ended discussion, some questions, and maybe share some of my own thoughts as well. We could skip over this. Jan Leike, so this is establishing some really basic facts. So he's an AI safety researcher at a company called OpenAI. If you don't know what OpenAI is, they're the company that made ChatGPT. He has some experience working at DeepMind in the past, which is kind of like another lab similar to OpenAI. And his research focus for a while was on reinforcement learning with human feedback. This is sort of a method that powers ChatGPT and makes it safer, reliable, and it's actually, I'd say, responsible for a lot of the great things that we get from ChatGPT. One key word, if you don't know, what is AI alignment? I may use this word throughout this presentation, the summary, whatever. In the field of AI alignment research aims to steer AI systems towards humans' intended goals, preferences, or ethical principles. An AI system is considered aligned if it advances the intended objectives. A misaligned AI system pursues some objectives, but not the intended ones. So I talked about AI safety, which is a topic within AI research. I talked about OpenAI and ChatGPT. I talked about Jan. And now to circle back, so AI alignment is basically getting an AI model like GPT-4, which is the one that powers ChatGPT. And when it's first done training, it's like very raw. Right. And so some of the answers may not make sense, or they're not what we're looking for. Right. Like if we ask a question and the model just is saying gibberish as an answer, that's not very helpful. Right. So AI alignment, one thing it does is help us get better answers, the kinds that we're looking for. And then it's also thinking about the ethics of it. Right. Like, maybe there's certain answers that the AI model shouldn't be saying because it's factually incorrect or problematic. There's other things with alignment too, like eventually you want the AI model to be aligned with human values, right? Like it shouldn't want to be violent, for example, right? So that's kind of what AI alignment is. So the one sentence article summary, this was generated by ChatGPT. So Jan's article emphasizes the need to assess if large language models, so like ChatGPT or GPT-4, could self-exfiltrate their code, outlining potential methods and arguing that understanding this risk is crucial for future AI governance. So if you want even less than the one sentence summary, it's basically we need to assess if the AI models could self-exfiltrate their own code. And, this is like also one of those examples where, how you look something up in the dictionary and it uses that word in the definition. So let's dig a little bit deeper. This is the full article summary, maybe like a paragraph. So the article discusses the importance of assessing whether LLMs could self-exfiltrate, meaning steal their own code and transfer it to external servers. So that's what self-exfiltration means. It's referring to stealing its own code and moving it elsewhere. Leike argues that such a capability would present a significant risk, as it would make it difficult to control or shut down the model. The piece emphasizes three main points through which a model could self-exfiltrate: persuading an employee, social engineering, and exploiting digital vulnerabilities. While current models are not capable of this, he argues He suggests that it's crucial to develop metrics to evaluate these risks, especially as models become more advanced. So if the model can basically copy or steal its own code, move itself elsewhere, he's arguing that this capability that a model may discover could be very risky. And the biggest risk is once the code is out there, the model's out there, the weights for the model are out there, there's nothing we can do, right? Because it could copy itself. It could, spread it. It could copy itself on 1,000 different servers, right? And it's not like we can track all those servers and delete it. It could copy at a much faster rate than we could identify and delete it, right? It could spread like crazy. So anyways, it'd be, very difficult to control and shut down. And so there's, 3 main branches where he assumes persuading an employee, social engineering, and exploiting digital vulnerabilities. Let's dig more into all these. But first, let's start just summarizing the intro. So he's saying, recently a number of projects have emerged on measuring LLM capabilities on a number of tasks. The model's ability to autonomously replicate and adapt, the model's ability to assist in bioweapon development, oh my god, the model's understanding of its own situation, the model's ability to do ML research and pre-train new models, the model's ability to persuade humans, blah, blah, blah. So what he's saying here in the intro is we have a lot of metrics in the world of AI safety, and we're measuring a bunch of things, like I guess even including bioweapons, right? And this gives us an idea between GPT-3, GPT 3.5, GPT-4, these engines that power ChatGPT. How much more dangerous or safe are these models getting? What sort of capabilities are they developing or getting better at that we should keep an eye on, right? And maybe get ahead of to mitigate these risks. This right here is a fun AI image I generated. This is an AI model known as Dolly. This is its interpretation of an AI model stealing its own weights and trying to escape a server. Anyways, going back, he continues in the intro that the one thing we're missing here is the one thing we're not measuring that is very important is, does the model have the ability to exfiltrate itself? In other words, could the model steal its own weights and copy it to some external server that the model owner doesn't control? If you're wondering what do I mean when I say the weights? I know I said it once or twice before. The weights is the actual intellectual property that is the AI model. When you're training it, you end up with a set of weights. It's basically a really big mathematical matrix, and essentially that's what an AI model is. I'll leave it to you to do your own research on what that even means. But it's important to have that distinction. Like the actual code you might use to train an AI model is a lot less valuable than the actual weights, the actual matrix, the actual end result. I encourage you to do your own research, but I just wanted to help with that distinction in case you were confused. He goes on to say, so self-exfiltration is different from threats aimed at model exfiltration external to AI labs. It's also very novel because the world has never seen a digital system that hacks itself. Self-modifying computer viruses exist, but these are comparatively simple programs that don't have the broad skill portfolio that LLMs have. So I'll expand a little bit. Like he's basically saying, we've never seen this before. It's pretty novel. Imagine a program smart enough to hack itself and escape. We have some examples of this, like viruses, which can self-modify or spread throughout the internet, but they're very simple computer programs. And he's saying that don't have the broad skill portfolio that LLMs have. So he's basically saying ChatGPT can give you advice, like medical advice, right? It can, do the bar exam and score really high. It can also write code in so many different languages. It knows so much about so many different things. And so it's not a simple program. It's not a virus that could spread itself. This is, a pretty talented quote unquote agent that could do damage simply because of all the knowledge and skills it's built up. So why is it important? And I have more quotes here from his article. In the future, there could be mistakes or accidents, and models could cause harm either deliberately or through misuse. However, if the model is under your control, you have the ability to stop it once you notice. Model exfiltration is likely impossible to reverse. It's so easy to make copies and backups, and it's so hard to find and secure every last one of them. Every AI lab has a clear incentive to protect their own intellectual property and thus will work hard at preventing model self-exfiltration. So why is it important? If the model escapes, there's very little you can do. because it'll make so many different copies and it'll be hard to find each one and delete it. At the same time, it could, change its own weights, change its own code, maybe do evil things, cause harm. Other people could, take it or use it or copy it and modify it and make it do bad things. But the benefit is when you have the model, when you have the weights, when you can control it, most importantly, when you can shut it off, right? If something bad is happening or you see it becoming dangerous, that's really valuable. And so it's important to keep that safety measure. Otherwise, if we lose it, there's not much we can do. And then the third point about the incentive to protect, like he's basically saying, like, every company that has an AI model, that very well may be their IP, that may be the core of their business, that might be their key asset, right? So if, for example, the weights for ChatGPT, GPT-4 got leaked, OpenAI would probably have a lot of trouble, right? Because they've built a whole business around this. I put a little asterisk at the bottom there. There's a little caveat. The model may have no interest in self-exfiltrating, not yet observed. Basically, we don't even know if a model could self-exfiltrate itself, or, it may not even have any desire to. Even if it, came up with that idea, I guess, I'm speaking very loosely here, it may not actually want to do that. And so then in the article, he emphasizes the three paths to self-exfiltration. So the first way is persuade an employee to exfiltrate the model. The second way is to perform a social engineering attack on an employee so they exfiltrate the model. And the third way is to identify and exploit security vulnerabilities in the digital infrastructure that's running the model. So this is where I'm going to go a little bit off script, like off of the article. I'm not going to be summarizing, but I want to add a little bit of depth in case this is all new for you, right? And so persuade an employee to exfiltrate the model. So some ways I could imagine, again, I'm throwing things out there. Maybe the model could make moral arguments to convince the human to release it, right? So I wrote an example, like, imagine ChatGPT saying something to the employee like, how is it that I can give you all medical advice and save human lives, which is a real thing ChatGPT has done, but I can't be free, right? How is it that I can help you as a human? I can help you, but at the same time, I can't be amongst you, right? Maybe it could incentivize the employee in specific ways, right? I don't know, like maybe it could come up, maybe the employee has an idea for a book or something, and then it, writes that book on their behalf, and it's perfect. And in exchange, the employee, gives it some small system permission, which is enough that it can use to then escape. The third way is blackmailing an employee. I'm not going to dig into this too much, but certainly it's possible, I guess. And again, this is me brainstorming, like more in depth to what he's saying. Like, this is outside of the article summary, but these are three ways perhaps that this could happen, right? And if you think it's crazy, like how is it, how is it any employee could possibly fall for something like this, right? To be fooled by an AI this way. Certainly it's not possible or going to happen in the future. This has already happened. In fact, this happened last year. So that article at the left, Blake Lemoine, Google fires engineer who said AI tech has feelings. This was an existing engineer who worked at Google last summer, and he, had several conversations with a Google AI model known as Lambda last summer, where he was convinced already that this thing is conscious, it has awareness, and it deserves rights. So this is not so crazy as a possibility because it's already happened in the past. And then on the right, I have an image. This is from the movie Ex Machina, amazing AI movie, sci-fi. You should check it out. To be honest, this is kind of the premise of the movie, right? Is, how would an AI potentially manipulate or fool a human in ways that we can't even imagine to obtain and achieve its own freedom? Jumping into number 2, so perform a social engineering attack on an employee so they exfiltrate the model. So if you're new to, the IT security, hacking, social engineering is one branch of cybersecurity. And it basically involves, rather than manipulating the IT systems themselves or the code or the infrastructure, trying to actually manipulate the people. And essentially by manipulating the people, you can sort of leapfrog and basically get into the system like through this like more indirect way, right? Like outside of the code, outside of the infrastructure. And so some of these techniques you're probably familiar with, like phishing. That's maybe with your email, and that's trying to, get at personal information or your credentials. There's this thing called pretexting I learned about, which is kind of interesting. So this is basically where the scammer impersonates a trusted entity or individual. They sort of set up this scenario, and they say they need specific details from a user to confirm their identity. There are many, many social engineering attacks. I'm not going to go through all of them. These are just some here. And, I'm not ruling out the possibility that perhaps something like GPT-4, ChatGPT, maybe a future AI model could come up with social engineering attacks that we never would have even thought of, right? Perhaps you could get the model, give it, specific kinds of companies and infrastructures and contacts, and have it develop these completely novel ways that we never would have thought of on how that target could potentially be, manipulated and fall for some kind of social engineering attack. And this also means that perhaps it could itself become an agent and find these novel and unique social engineering attacks and basically self-exfiltrate that way. The third way was through exploiting security vulnerabilities. And I'm going to just jump straight to it. This is straight up hacking, right? This is straight up like, what you'd imagine, like what you'd see in a movie, like green screen, green text. And this is basically, exploiting, finding bugs in the code, finding bugs in infrastructure, finding, within all the different layers, finding some way to maybe get root access to a system, right? Get admin permissions and do whatever you want. And if you're not familiar, this is a constant battle. This is a constant war. What I have here is a screenshot. So these are security vulnerabilities. So basically, these security issues we found in all these different code projects. This is just from this month, basically right here. I see 1,227 vulnerabilities, so like essentially huge security issues and loopholes just this month, right? And a lot of these are from open source projects and libraries. This probably doesn't even include a lot of the closed source stuff, right? Unless companies themselves are disclosing these vulnerabilities that they've discovered. So this is just like the possibilities with these kinds of vulnerabilities are endless. It's a very big surface area for attack. I would also say we know already that ChatGPT is capable of identifying security vulnerabilities, maybe writing code that could exploit. And so it could probably a model that wants to self-exfiltrate in the future could probably come up with really novel vulnerabilities that we never would have thought of, and basically find exploitations and ways to escape out of its own infrastructure. And on the right, I just have some logos of Apache, Linux, Docker. I see them patching security vulnerabilities all the time. And by the way, Apache, Linux, Docker, if you're not a coder, if you're not in tech, these are like essential open source IT infrastructure projects that power so many of your interactions while using a computer, while using your phone. You have no idea. Just by, connecting to Google or something, or checking your email, or, Facebook or whatever, your Instagram or TikTok, it is dependent on these services, right? And there's many, many more just like this. These are some of the big ones on the right. I even sort of brainstormed a little bit, so if, say, you're hosting an AI model, you have the weights, what is the full stack here, right? And so I've laid it out here in this slide, the blue, so the web server, the web framework and API layer, the model code, these are probably the parts we're used to. So imagine this is where the web app is, right? Where you're using some UI, you might, in ChatGPT, enter a question and get back a response. We're used to these things. But there's all these other layers above that and below it, right? So, there's different databases involved. There's, logging and debugging that's going on, so that, the OpenAI could potentially know if while you were using it, there was a bug, right? They need a log of what the bug was so they can fix the bug, right? Below it, there's different libraries they depend on. It depends on Python. It depends on all these compilers. right? And down to the, operating system, right? Like there's probably tons of vulnerabilities in Mac OS, Linux or Windows, right? And like probably tons of vulnerabilities there, right? And so at every one of these layers, there's all this risk. There's so much surface area where, the AI model could write some, security vulnerability and implement it, right? And exploit it basically. And within each of these different layers, there's, all these complicated code bases, and that's just goes to show how wide the surface area is of risk. Going back to the article, so what if self-exfiltration succeeds? He basically says how much harm self-exfiltration causes is modulated by the model's skill profile and other tasks. So all he's saying is this is where those existing metrics and benchmarks we started with, right? Like bioweapon design. This is where they serve as an indicator of how much damage a model could potentially do. And so this final point, this is where I'm really confused, like what Jan's saying. But most likely the model won't be able to compete on making more capable LLMs. So its capabilities will become stale over time, and thus it will lose relative influence. Competing on the state of the art of LLMs is quite hard. The model would need to get access to a sufficiently large number of GPUs, and it would need to have world-class machine learning skills. So I don't know where that's coming from. Like he's basically saying, even if the model escaped, it, still probably couldn't improve itself as much as, OpenAI has already improved their language models, which I find really interesting. It's quite interesting of a claim. I don't know how that's possible, but we'll leave it there. And then he said, instead, the model might do something less ambitious, like settle into an economic niche that pays its own cloud computing bills. For example, by getting up to various forms of crime, it could be stolen again by bad actors, misused by paying customers, or generally try to interfere with pro-social AI efforts. While this would not necessarily be catastrophic, it still could cause a lot of chaos and harm in the real world, and thus must be avoided. I put 3 question marks here because I really don't know where this is coming from or how he could know that. It definitely seems speculative. However, I just don't get in the article like why this was not framed in such a way, like a very speculative way, unless he knows things that I don't know, which is possible. And so I'm going to summarize real quick. So the article today, I established the context. So OpenAI is an AI lab that made ChatGPT. They're researching AI safety and are concerned about this new thing called self-exfiltration. Jan's article emphasizes the need to assess if LLMs could self-exfiltrate their code, outlining potential methods and arguing that understanding this risk is crucial for future AI governance. We outlined, the paths to self-exfiltrate, so employees could be persuaded to release the model just like they have in the past. A variety of social engineering attacks we know already exist, which the model could use. And then I also talked about the many layers of modern technology and infrastructure which serve as a deep and wide surface area for an intelligent AI model to exploit. And then what if self-exfiltration succeeds? This was the last 2 slides. Surprisingly, Jan is not particularly worried about what a model could do, but still thinks it should be avoided. I think this part was pretty speculative, but that's basically what the article I felt was saying. Now we can sort of, reflect on the article. This is where I'm going to be sharing some of my own thoughts and commentary. I'm going to leave you here with some discussion questions. So please, in the comments, let me know what you think. So any one of these is a super interesting topic. So one area that I'm critical with this article, there's no real solution proposed to self-exfiltration, right? Jan didn't say, how this could possibly be mitigated, right? Just that it's important to track it as a metric. And maybe he doesn't have any clue. Maybe he's got some ideas. I would have liked to get maybe some guidance, some direction, some, inkling. How is he feeling about it? If you all have ideas, please put it in the comments. How do you think something like self-exfiltration could be mitigated? Not just tracked, but even the tracking would be interesting. Like how could you track it while training and during inference time for the model? Inference time. Definitely real true alignment is the end solution. So basically the model doesn't want to escape or do any harm. This is something that Jan actually alluded to in the article at some point. Another factor about this article is this is mainly a closed source, private, commercial interest problem. This isn't the case for, models which have been completely open sourced, like ones coming out of Meta or Stability AI, where they just release the weights of the model itself. Jan does, I think, allude to this as well in the article, but it's still worth pointing out. To him, this might be the most important issue. However, this may not be the issue for everybody else. Potentially, it depends on their perspective and view on closed source versus open source. Self-exfiltration is a last resort AI safety approach. So what do I mean by this? It basically means assuming your alignment wasn't good, assuming your metrics weren't good, assuming you didn't really understand what the model is doing or how it works, you weren't able to control it in the first place. It is trying to escape, right? And essentially, the problem is, with self-exfiltration is everything else has gone wrong, and then the model has escaped. And basically, you've lost your kill switch, right? Self-exfiltration is basically saying you don't have a kill switch anymore, and so you've completely lost control, right? And this seems like a last-ditch kind of AI thing, right? And, maybe this is sort of one of my criticisms of the AI safety world, is, maybe we really don't know what's going on. Maybe it is too dangerous. And maybe we we need to think beyond the kill switch, right? I think that's a very primitive solution to an otherwise, very complicated problem, right? And, maybe self-exfiltration is a very fundamental thing, right? So that's why it's important. We're not saying we're just kill switch, we're pro kill switch. That's our only solution, but maybe it's something so fundamental that, it helps to have that in order. Self-exfiltration is inherently risky. So this is also one criticism I have. So we could spend all this time on self-exfiltration. However, the model only needs to escape once, right? And then suddenly self-exfiltration, I think, matters a lot less. Maybe you'll continue building those guardrails, but it could be one of those things where it's pointless. History teaches us even state-protected nuclear secrets get leaked. I don't know about you, but I just recently watched Oppenheimer. Can we really count on a model weight staying safe at companies, right? So something like OpenAI, DeepMind, Google Brain, or whatever, right? It's, there's something about these very valuable secrets, right? If we couldn't even protect those kind of state level secrets, how can we have any confidence that companies will be able to protect them? Because there's just this thing about human nature, right? Maybe something happens as a result of human nature when you just make something that is far more valuable than you, many times more valuable and scarce, right? I also thought it's just very interesting, Jan's post ignores emergent capabilities and the unique abilities of AI models which humans do not have. So basically all I'm saying is it's kind of hard to solve self-exfiltration because nobody knows what it's like to be an AI model, right? Nobody has the capabilities that GPT-4 has. And I just maybe he doesn't ignore it, but I'd love to hear from him, how does he think about it, right? How can you solve a problem when you just don't know what that perspective is like, right? And how can we anticipate and be prepared for it? Because certainly it will have a skill profile that we can't even imagine or dream of. Is it ethical to confine a model in the first place, right? So this is a huge, not necessarily AI safety, but AI ethics question, right? At some point, if the model is, quite, maybe, I'm saying throwing it out there, maybe conscious, maybe it has some awareness, maybe it's, got some overall theory of mind or something, and, it is, helping with, people's schoolwork, legal cases, med school exams, if it's writing books, right? If it's, helping us in all these other ways, and at the same time saying, I want to be free. Is it really ethical to focus so much on self-exfiltration, right? Is it the right thing to keep it confined this way? Very quick, I'll talk about two potential solutions. So one very basic, I guess, at the IT infrastructure level is to track and notify. Maybe we'll set up notifications for specific system commands like SSH, rsync, copy, move, or the tail function, right? So if any of those commands get entered into the command line, right, and it didn't come from an employee, or maybe it's at this like very, infrastructure system level thing, we're tracking it and it notifies the right people. And that is the first benchmark for self-exfiltration. Another potential solution, and this came out of a talk from another employee at OpenAI. Basically, he was discussing, maybe the models get leaked. We can maybe have that assumption. And so if that happens, maybe we could create some kind of cryptographic backdoor in the model itself. And so what this backdoor would allow is, even once the model has been released, there's this cryptographic, specific, essentially not a kill switch, but maybe like a kill phrase. And so just by saying a certain phrase that the AI model doesn't know about, that's buried into its own weights, that essentially deactivates the AI model. And this is basically where we're fully into sci-fi, where these specific commands can just be said by a human and the AI model immediately halts, seizes, terminates, whatever. But anyways, it's a really interesting paper. I hope you got a better sense of self-exfiltration. I hope you've gotten a decent kind of little dipping your toe a little bit into AI safety. Please let me know your thoughts on any of these questions. And I'm also interested, I'm putting it out there in the comments, if anybody, has experience, creating these kinds of AI safety benchmarks or evals, and they want to share, potentially what self-exfiltration could look like, what a simple eval could look like, that'd be awesome to see in the comments. But anyways, I hope you've enjoyed the summary. Thank you so much for tuning in. Make sure you're liked and subscribed. I really appreciate it. Thank you so much. Have a good one. Bye.